All right. So now that we've convinced ourselves that amplifiers are generally a good thing to have, they're useful in both the analog and the analog domain, and amplification is good in the digital domain as well. Let's now look to see what an amplifier really looks like and how we might build one based on some of the components that we've seen so far. So before I do that, let me play around with the amplifier abstraction, the amplifier box a little bit, and then we can go into trying to build one. So an amplifier is really a three-ported device. Okay, previously in the very abstract notion, I showed you an amplifier looking like this with an input and an output, where some waveform at the input was amplified at the output. An amplifier is really a three-ported device, has three pairs of terminals, and there is the input port. Okay, it has a output port, and there is a power port. Okay, one of the key things that amplifiers do is they provide power amplification. Okay, in other words, you can have an amplifier that amplifies voltage, but oftentimes we need to amplify power to get something useful out of the amplifier. And so in this case, you look at the power going in. So for example, if I have a VI at the input and a II at the input, then the power is given by VI, II. And then I have a output port, VO, and I write that down as IO. Okay, there is some power provided by the amplifier at the output. Okay, that power relates to VO and IO. And so this amplifier provides power gain if the power provided at the output of the amplifier is greater than the power that is consumed by the amplifier at the input. So in situations like this, when it's amplifying power, the power must come from somewhere. Okay, and usually what happens is that there is a power port and there's a power supply connection where power is input to the amplifier. Okay, so this is my amplifier circuit, the amplifier abstraction. Now, commonly, we could have amplifiers that look like this, but commonly we draw an amplifier in the following manner. Okay, we make some connections as follows. So I have my input and output ports as usual. So let me draw out my input and output ports. Very commonly, we will take one of the ports as ground. So we have a common ground for both the input and the output. And then for the power port, in the same manner, we would commonly have a ground connection, and I would have a power connection up here. Okay, so I would have a power connection with respect to ground, from input with respect to ground, and I take an output with respect to ground. Okay, so this is another common connection for my amplifier. Now, very commonly, we will not end up showing the power port. Okay, so this part here and this part here are very commonly not shown. Also, for convenience, as I said, we observe the common ground discipline, which is providing a common ground connection for the amplifier, both at the input and the output. Okay, so the reference ground is taken to be the same. Now, in many amplifiers, this may not be true. There is one class of amplifiers called differential amplifiers. And in differential amplifiers, I don't take a ground at the one of my pairs of inputs is not a pair of input terminals, is not a ground connection. I take a differential signal. We'll see some of these later on in the course. And while the output may have a ground connection. Okay, but by and large, while there are exceptions, these are commonly adopted principles. Okay, so that's enough for abstract amplifier devices. And so the question for ourselves is, how do we build ourselves an amplifier? Okay, you've seen a bunch of devices and elements so far, resistors and dependent sources and independent sources and so on. How do we build ourselves an amplifier? Okay, so what we're looking to do is going to look inside an amplifier and see how do we build an amplifier on the inside? Okay, what are the components and how are those components connected inside the amplifier? But notice that once we build ourselves an amplifier, then commonly we will just take a box like this and be able to build circuits by connecting such boxes together. Okay, we will build abstract devices called an amplifier. Okay, and so for now, let's go in and look inside and see how do we build ourselves an amplifier. Okay, so surprise of surprises, you already built an amplifier. Okay, I try to think back on where you might have built an amplifier, but here's where. So recall this little dependent source circuit that I showed you earlier, where you had a dependent current source, where the current was given by ID is k divided by 2 times Vn minus 1 whole squared for Vn greater than 1 and 0 otherwise. And we had an input VI source. And so this was a little circuit we'd looked at before. Okay, I claim that this is an amplifier. Okay, let's try to understand this. So before I try to justify the claim that this is an amplifier, let me just refresh your memory in terms of the basic equations that we had for this circuit. So recall we'd applied the node method, and by the node method, we'd computed the relationship between V naught and Vi. And so we had a connection between V naught and Vi here. And we did that by applying the node equation to the node with the voltage V0. And so I summed the currents to zero out here, and then I rearranged my terms here. I substituted for ID out here, and that's how I got my V naught equals some function, some Vs minus k by 2, Vi minus 1 whole squared times RL. Okay, so I got my V naught as a function of Vi. So we've seen all of this before. Okay, so my claim is that this is an amplifier. Okay, so let's go and take a look at it and see if we can convince ourselves that what we have is an amplifier. Okay, in that if I could create a dependent source with the following property, then by using this connection, I could build myself an amplifier. Okay, and again, remember, I haven't shown you how to build a dependent source. Okay, so the dependent source itself is a question mark. But suppose you had an abstract dependent source device that looked like this, then I'm going to first convince you that you could build an amplifier using this connection. Okay, so let's keep this in mind. Let's put a star on this equation and keep it in mind, and then go and look at equation in more detail to see if we indeed have some amplification.